Hi everyone, and welcome to the second video introducing Microsoft Azure's core services as part of the AZ900 assessment preparation. So in the last video we were just going over a general introduction to cloud services, a bit like we did last week in week one, from a Microsoft centric point of view. And now we're going to be looking at some of the core services that Azure offers, and these are specific to Microsoft, although similar offerings will be made by other cloud providers in their own unique way. Whereas the last session was a whistle-stop tour of the general aspects of cloud, this will be a bit of a whistle-stop tour of the services. Now, this video is just going to introduce and detail some of the main concepts and uses of these services. There's a whole host of interactive activities that you'll do through the Microsoft Learn platform in a self-directed way on Tuesday and later on in this course, so this week and next week and beyond possibly. And those will get you to do things like create a database on Microsoft Azure portal, to create a serverless computing situation or a virtual machine. So you'll do that all in a self-guided way using Microsoft's resources. It's the best way of doing that in an individual way that you can then remember. So, as with last time, the first thing we're going to do is look at what learning objectives are. So we need to be able to understand and describe core Azure technical components. Understand and describe the services and the products, the solutions, and the management tools. So, core Azure architectural components. Now, the first thing we need to think of is the regions and geographies, and this was mentioned previously in one of the presentations at the end of the week last week. So, a region represents a collection of data centers. This provides flexibility and scale. So, there are 54 regions for Microsoft's services representing 140 different countries. Okay. This preserves data residency, either data is stored in the general location in which it's being called from or used. You can select regions close to your users so that the communication of information and data requests and storage setup is much more rapid. You need to be aware of region deployment availability, but there are global services that are region independent as well. Talking previously about the high availability and fault tolerance in the Microsoft Azure system amongst other cloud providers as well. Now, the way that they do this, amongst other things, is to pair up regions. So each Azure region is paired with another region. Now, it prefers at least 300 miles of separation between data centers in a regional pair. So if something goes wrong at a certain data center or in a certain country, then there's at least 300 miles of separation between the NAT and the paired data center. And that way, the paired data center should be safe and secure and not subject to the same issues as the first one. Some services provide automatic replication to the paired region, i.e. automatically copying that. In an outage, recovery is one region is prioritized out of every pair. Now, the Azure system updates are rolled out to paired regions sequentially, i.e. they update region 1, then region 2, never region 1 and 2 at the same time. And this preserves the security and the reliability of the system. Paired regions are, wherever possible, members of the same geography though, except for Brazil. Now let's think about these geographies. So geographies are discrete markets that provide data residency and compliance boundaries. They typically contain 2 or more regions in a market. They allow customers with specific data residency and compliance needs to keep their data and applications in close proximity, categorized as the Americas, Europe, Asia Pacific, Middle East, and Africa. And you'll notice if you're surfing the web recently, one of the recent trends over the last 18 months has been the need to request for user cookies within Europe. So that update will naturally have been scaled and rolled out to all of the Europe regions and the Europe market as a whole, but it won't have generalized to other markets because they don't have the same rules and GDPR compliance and things that there is in Europe or America or in Asia. Now, in terms of availability, from a virtual machine point of view, so a single virtual machine, you've got 99.9% of them have premium storage. In terms of availability sets, so you're protecting against failures within data centers. Here we've got virtual machine service level agreements with an availability and premium storage of 99.95%. And then for an availability zone, you've got a VM uptime and storage of 99.99%. So you've got multi-region disaster recovery going on very easily here. So let's just dig down into what availability sets are. These keep applications online during maintenance or hardware failure. Now you've got update domains, so scheduled maintenance, performance or security updates are sequenced through update domains, either happen in one domain, then the next, then the next. And that would be the individual cells of this structure. Now fault domains would be the columns of this storage structure. Fault domains provide a physical separation of workloads across different hardwares in a data center. And this allows for Six Sigma, amongst other things, security and reliability. Now beyond this, we've got availability zones. These are physical separate locations within an Azure region. This takes availability sets to the next level, including one or more data centers equipped with independent power, cooling, and networking. So if there's a power fault or a cooling fault or something's gone drastically wrong in one data center, the next zone will be absolutely fine. Multiple zones form as a region, and this acts as an isolation boundary. Now, in terms of resource groups, we've got multiple different uses for these. So web and database, virtual machines and storage, they might be in one group, or they could be individually resourced, just like it shows on the right here. Now this could be done using containers. So you're going to have one container for multiple resources that share the same life cycle. This aggregates resources into a single management unit. So rather than thinking, my data is stored in this instance and my cloud networking solution is stored there, my website is managed here, my virtual machines are managed here, it's all just in one container resource group. So every Azure resource must exist in one and only one resource group. This security at the resource group level using role-based access control. So one of the core Azure services that you may become familiar with over time, if you're working as a cloud engineer, will be Azure Resource Manager. So this gives you that management layer that enables you to create, update and delete resources in your Azure subscription. So creating, configuring, managing and deleting resources and resource groups then. It lets you be far more organized about what resources are all held within the containers and what's going on. And you can automate using different tools and software development kits or SDKs. So the first core Azure tool and service that we're going to look at is Azure Compute. So this is on-demand computing service for running cloud-based applications. It provides computing resources such as disks, processors, memory, networking, and operating systems, like virtual machines. Essentially just running a computer that's not your own in the cloud. So this makes resources available in minutes or seconds, depending on uptake and popularity of the use at the time. And there are lots of on-demand services, entirely pay per use. Now, in terms of the services, we've got Azure Compute Services include Azure VMs or virtual machines. They use infrastructure as a service, or IaaS, to provide computing power in the cloud. Then you've got VM scale sets, and these are designed for automatic scaling of identical virtual machines. App Services is a platform as a service offering to build, deploy, and scale enterprise-grade web, mobile, and API apps. Generally, anything that's a cloud-based that runs, multi-app service is going to be running something like this. And then you've got functions as well, and these perform compute actions based on a specific event. Containers are a virtualization environment, but unlike virtual machines, you don't manage an operating system. They're meant to be lightweight and are designed to be created, scaled out, and stopped dynamically in the middle of a job or remotely entirely. So you can have Azure container instances. That would be a platform as a service offering that allows you to upload your containers, which will then run for you. Or you can use something called a Kubernetes service. And this is a container orchestrator service for managing large numbers of containers. It's called an orchestrator, partly based on the idea that it works like an orchestra and that you would be the conductor for that orchestra. Now, in terms of network services, you can have Azure Virtual Network, which provides secure communication between Azure resources. Load Balancer, this automatically scales to create highly available access to applications or resources. Virtual Private Network, or VPN Gateway, is a platform-managed, scalable, and highly available application delivery controller. VPNs are particularly important if you're trying to communicate secure information remotely. So you need to be working on a virtual private network to make sure that people externally can't grab that information from an unsecure connection. And we've got Azure Application Gateway, and this provides for the management of traffic to web applications. And this is one of the security offerings that helps avoid denial of service attacks against websites, amongst other things. If you're not familiar with that, just have a Google about denial of service attacks, or DOS. And then we've got content delivery frameworks, which provide a distributed network of services that efficiently deliver web content in their local region. Now, when you go through the self-guided material, you'll be creating a virtual network and virtual container instances in Azure, as well as a virtual machine. Now, moving on with the theory part of this. So Azure data categories. We've got structured data, semi-structured data, and unstructured data. Now, structured data adheres to a general schema or structure or setup with the same data fields or properties. The relationships will be storable in a relational database tables, so it'll be able to be stored in headings, rows, and columns. Examples might be sensor data and financial data. So on this date, at this minute, the price of this stock or share was this. It was previously this value. It's expected to go up to this value. That's got a nice structure. Then we've got semi-structured data. This might have a bit of a ad hoc or as required scheme or schema with less organized fields and properties. So the data relationships here would be non-relational or no SQL, which I introduced last week. So not storable in tables, rows, and columns. So an example of this in terms of the data might be books, or a blog, or website HTML documents, or JSON files. You may have heard of the term. So this is stuff that you can't just put into a row and column table in terms of the information. You couldn't just put a book into a table with all the information from that book, the chapters and the structures in that, and the general themes from that book form something in terms of the semi-structured data aspect, but you can't just row and table that easily. Then we've got unstructured data. This is where you've got no designated schema or data structure. So the relationships for this would be called non-relational or blob data, with no restrictions on the kind of data blobs contain. Examples might be PDFs or JPEGs, pictures or videos. So Azure Storage Services, if we break these down into infrastructure as a service and then platform as a service to segment them. In terms of disks for IaaS, you've got persistent disks for Azure VMs. Premium storage is available, and the disk option might be SSD or solid state drive based, high IOPS and low latency, i.e. very quick and powerful machines for doing lift and shift operations, moving stuff, doing heavy computes quickly. In terms of files, you've got access to the REST API and SMB as well. Feel free to Google any of these acronyms, break them down in your notes and make sure that you remember them later. You've got access from anywhere in a secure way. Then if we move on to platform as a service, you've got containers with unstructured data, for instance, and all the different blobs that you might have going on there. You'll get an example to work through creating blob storage on Microsoft Azure when you go through the self-directed material tomorrow. Now, in terms of tables, we've got NoSQL data structures, dynamic scaling, 2 petabytes of data, so massive storage facility and availability there. And then you can do very, very fast looking up of data to get specific information out. And that's really valuable to an organization if you're working on something that needs quick response information. You can easily store and retrieve messages from queues and scale very well. Now, in terms of database services, the Azure Cosmos DB is a globally distributed database service that enables you to elastically and independently scale throughput and storage. It gets much bigger and smaller depending on the amount of information that's in there, and you can control that to and limit that. What I think a lot of you are going to be interested in is the Azure SQL database. So this is a relational database as a service, so DAS or database as a service, based on the latest stable version of the Microsoft SQL Server Database Engine. Okay, you're going to get time to play around with creating and inserting data into an SQL database on Azure when you go through the self-guided materials, and then we'll build on that later on in the bootcamp. They also offer database migration in Azure. This will be a fully managed service designed to enable seamless migrations from multiple database sources to Azure data platforms with minimal downtime. There's a whole host of other database offerings too, but these are some of the headlines. Then it's worth mentioning about Azure Marketplace. Okay, so this connects end users with Microsoft partners, independent software vendors, and startups that offer solutions and services for Azure. So this is where Azure customers, IT professionals, and cloud developers can find, try, purchase, and provision Azure applications and services from the certified, so Microsoft approved vendors. There are about 10,000 product listings currently on the Azure Marketplace. This is just a nice, easy way for your organization to find the solutions to problems that may not exist easily or freely on the web, but that someone will have solved more than likely and be able to help you with through the marketplace. So those are some of the services. Now let's talk about the solutions on Azure. So we've just got 2 examples of the Internet of Things offerings here on Azure. So we've got IoT Central, and this is a fully managed global IoT software as a service solution that makes it easy to connect, monitor, and manage your IoT assets at scale. So if you've got multiple different devices that are communicating with each other, you can manage those through IoT Central. And then we've got Hub. This is a managed server hosted in the cloud that acts as a central message hub for bi-directional communication. So not just getting data from multiple devices, but also sending commands back out too. Now, if you've got big data, remember the woolly definition I gave for big data is more data than you can store or open easily on a single machine or a single application. So you've got solutions available to you like Azure SQL Data Warehouse that leverages massively parallel processing to run complex queries where you're asking the database to return specific or general information. And it can do that using multiple machines to massively speed up the process of search. Then there's HD Insight. So this is a fully managed open source analytics service for enterprises. So the analytics part of this will do some of the data manipulation and data analytics and reporting aspects for you that you need in an organization where you've got a data-rich service. So it's a cloud service that makes it easier, faster, and more cost-effective to process massive amounts of data. And then there's the data lake. So this is an on-demand analytics job service that simplifies big data. Instead of deploying and tuning hardware, you write queries to transform your data and extract valuable insights. Typically, it used to be used as an example with data lakes before Azure even came around, that you would have the data lake and you'd need to just go fishing and see what you'd caught out of this massive lake. Now what this is trying to do is partition the lake and manage that and dam that to try and find the most valuable insights and make the most out of the lake. Now, in terms of AI solutions, you've got the Azure Machine Learning Service. This is a cloud-based environment used to develop, train and test, deploy and manage machine learning models, as well as track them. This is typically done in a drag and drop scenario, and we'll talk about that later on towards the end of the bootcamp when we're preparing for the Azure AI certification. And then there's a Machine Learning Studio. And this is a collaborative drag and drop visual workspace where you can build, test, and deploy machine learning solutions without needing to write any code whatsoever. Now, it's important to mention that you can get serverless computing as well through Azure. This is a relatively newer terminology. Okay, so this will be functions, for instance, that are code running your service and not the underlying platform or infrastructure. So it creates the infrastructure based on an event or based on what's required of it at that time. You've got Logic Apps, and this is a service that helps you automate and orchestrate tasks, business processes, and workflows when you need to integrate apps, data, systems, and services. So get data from this system, push it to that service, make sure that it's doing this solution and meeting the client's needs. You've got Amazon Azure Event Grid. So this is a fully managed intelligent event routing service that uses a push publish service model for uniform event consumption, i.e. everyone's getting the same bit of information at the same time. So in terms of DevOps or development operations, this is a part of the software development background area. So Azure DevOps Services provides development collaboration tools, including pipelines, Git repositories, and we will come to GitHub later on in the course. Some of you may be familiar with that. Others likely aren't. Don't worry. It's just a brilliant relatively new tool to be able to share and work on the same code at the same time and to make sure that you've got proper version control going on. And then we've got Dev Test Labs. This allows you to quickly create environments in Azure while minimizing waste and controlling the cost to test out what's going on. You've got the Azure App Service as well. This allows you to quickly and easily build web and mobile apps for any platform device. And I don't need to tell you how valuable that can be in the cloud without needing to have all of the devices in front of you. If you can build pretty much one application and then simulate that on all platforms and devices. Now, in terms of management, from an IT management point of view, and this is probably beyond what you'll be working at in the first instance, but worth mentioning so that you're aware of these tools and techniques and the terminology really for when you're going into work. So you've got multiple different management tools for different things. So you've got the Azure portal, which you'll become familiar with over the next week and a half. Azure PowerShell and Command Line Interface, or CLI. Cloud Shell, mobile app as well to give you that extra level of control. If you've got Azure services running in your organization at a relatively smaller scale, you might want to use the mobile app. And then there's the REST API as well. And if you don't know what REST API is, I'd really encourage you to just go away, search that, watch the videos, and get comfortable with what that is. And then there's the Azure Advisor. So this analyzes your deployed Azure resources and recommends ways to improve availability, security, performance, and costs. So how you can make the most out of the cloud. You get proactive, actionable, and personalized best practice recommendations there, allowing you to improve the performance, security, and availability. So that's the end of this session. You should have done the quiz already to do the knowledge check from the first video. If you haven't, then I encourage you to go back and do that. The next activity for you all is to go and create a LinkedIn profile if you haven't already got one. So set yourself up, give a bit about your employment history if you have any, but don't worry if you don't. Just set yourself up there. Put yourself in as a member of the Institute of Coding Bootcamp with Birmingham City University, and then find me on LinkedIn and connect. Not just to me, but to each other as well. Share your LinkedIn profiles and start to build up that network that will support you later on when you're working. Thanks for watching.